Maybe. Yeah, he's actually going to do something for once. Solubility. If you have a really, like, something that isn't soluble, like silver chloride, a little tiny bit of it will dissolve, but not very much. You can use equilibrium to model that. But yeah, so this we'll go over next week, all this I guess. And then KP is what we're going to talk about right now. KP, you find the equilibrium expression the same way you do Kc. So instead of concentration, right, in the square bracket, you would just do partial pressure. So if I have like a box with 3 different gases in there, and I want to find my equilibrium stuff, then I would use the pressure of this gas, pressure of that gas, pressure of that gas. And you'll be given, like in your problem, you'll be given the pressure instead of concentration, so you'll know to use Kp instead. There's a way to convert between them. The equation's up there. Kp equals Kc times RT delta N. It occasionally shows up on Chem Olympiad. If you want to memorize it and like get that question right, if it shows up, great. If you don't, whatever.
You just got that from ideal test, so you don't have to memorize it.
Deshaun, everyone can't process stuff like you do.
Damn.
Like most of us really don't care about deriving equations in the middle of a test.
No, we don't have to memorize it.
That's true, but most of us don't care about deriving equations in the middle of a test. Okay, so I have like a practice worksheet thing for you guys if you want it. And there are a couple problems that use Kp instead of Kc, so I figured you might as well go over it. But yeah, so if instead of concentration they're given pressure, same way, written the same way, but just plug in your pressure instead. Okay, so for example, find a Kp for the Haber process. Given Kc, our equation is Kp times RT delta N, right? Delta N is gas molecules, the number of gas molecules, or more probably the change in, final minus initial. R is 0.0821, temperature is whatever temperature you're at. Okay, so Kc we know is 120, get that. R is 0.0821 times 273. Anyone got a calculator out? Times 5. Delta N, what is delta N? Do you guys remember that Haber process? Should I write it up here? Yes. How many gas molecules do I have here? 2, right? How many do I have here?
4.
Count?
Oh my god.
Okay, so what's my change? Final minus initial.
-2.
-2. Yeah. So if we assume that 0.0821 times 273 is equal to 5, which is totally perfectly accurate, that would be 120 over 25, which is approximately equal to 5. That's how we do math, guys.
27.
Negative charge again?
What?
Did you get -2?
Delta N is
Hold up.
number of gas minus initial, right?
Yeah.
My final, over here I have 2,
Yeah.
over here I have 4.
Oh,
So
where
I
do you
started
have
with
5
started with
from?
2, 2 minus 4 is -2. Okay? Alright, so equilibrium is when our rates are equal, right? But then sometimes if we change stuff, which is when, if I have this reaction, A plus B turns into B. Just like conceptually, if I have this reaction and it's at equilibrium, okay? If I add more B, what's going to happen? More C. That's about it. That's the Châtelier's principle. So that it's basically saying if you apply stress to your system, you will have a change in your position of equilibrium. That basically you'll make more products, you'll make more reactants, depending on which way that stress is applied. So the mathematical way we do it is we calculate Q, which is the same thing as K, something the reaction would be phi over b times a. And then we compare q to k, and if q is less than k, that means that our reaction is going to shift to the right, and if it's greater than k, our reaction is going to shift to the left. Let me explain what I mean by that. Okay. There are three ways to change where equilibrium is at. So basically, three ways to change q. That's changing the amount of stuff I have, changing the temperature, or changing pressure. And really, there's a shortcut for this that can kind of just tie into that. It's not like accurate mathematically or whatever, but it works. It's fine. Yeah.
Pressure type.
What?
Temperature type pressure.
Kind of.
So increasing temperature equals pressure.
It would, but normally we kind of assume that we're holding everything else constant. Like the problems that you get won't expect you to bring together all these different things. Okay, if q is less than k, we shift to the right. If q is greater than k, we shift to the left. Very infrequently will you be asked to actually calculate q and figure this out mathematically. So you don't really need to know that for Chem Olympiad, or really like until next year in IB Chem you will learn this, how to calculate q and like actually use it and stuff. But for now, let's just look at it theoretically.
We don't remember.
You're posting the video, right?
Remember?
Like, I remember doing it. Like,
Just send it to like each and every person.
no, I remember what it is. We're
Okay,
asking you.
Something to note,
Oh, I did that last
adding or removing chemicals does not change Q. Or does not change K. It will change Q. And then we compare Q and K and see which way is my reaction to shift. What am I going to make more of? What am I going to make less of? But it will not change my equilibrium constant. It's constant for a reason. The only thing that can change is temperature. Okay, so like you just said, if I have a reaction, A plus B turns into B, and then like B turns back into A and B. If I add B, I'm going to make more C, right? If I add C, what's going to happen?
Make more and B.
Make more and B, right? If I remove B, what's going to happen?
Less.
Less C, right? Which means more C is going to be turning back into this. And then removing C would mean
Left
to go
B,
that way.
yes, and
Right? Does that make sense? It's pretty self-explanatory, right? It makes sense. Like, if you think about it in terms of what equilibrium is, this is the forward rate, and that's the reverse rate, right? Let's say like you're washing dishes, right? And you're washing dishes, and your mom comes by and drops a huge stack next to you. What are you going to do? You're going to wash them, right? Like, you want to be done with it. Like, oh my God, Mom, why would you do this? So you're going to start washing faster. Okay? You're going to be like, I want to get out of here. Your rate is going to increase.
Metaphors.
This is metaphor. Don't you make a metaphor? Okay. So if I add more B, right, my rate is equal to something like this. If I add B, my rate is going to go up, right, which means that this is going to increase. Eventually, I'll make more C. Right, if I have A and B, and I'm making more C, then my concentration of C is going to go up, which means my reverse rate will go up, and they'll reach equilibrium again, eventually. But at the beginning, forward rate is going to be bigger, so we'll make more C and we'll decrease A and B. Okay, with pressure, we're going to shift to the side of the reaction with the left gas molecules. Bye, guys.
Bye.
Oh, hey, before you go, just a quick note. So Chem Olympiad is in like 2 weeks from yesterday. So what we're doing next week, we're going to be meeting Tuesday, Thursday, and Friday, and then the Tuesday the week after that. If you can't make any of these meetings, that's totally okay. Don't worry about it. This is mainly meant for like people who either A, seniors, or B, like you think you actually have a shot at maybe making top 12 or whatever. So anyone's welcome to attend, but like, yeah, that's the gist of it. So we're going to be covering like acid base, we're going to be covering KSP, just review kind of stuff, and then the
Can you send me an email with the list of everything?
So up to the Northville High School at 7. Pay money, buy food. Bye.
Why?
It's at 7.
What's in it for me?
Is it like a sporting
No,
event?
there's like a dancing.
It's
Oh.
the ice thing.
Alright,
It's
so
like North Pole.
all I'm hearing are like reasons
It's
why
like
I
all the
shouldn't go.
schools.
I
Yeah.
have to go somewhere, I have to pay money, I have to dance.
You should come laser tag with me and some people you like Saturday night. You'll like it.
Maybe.
You'll
Okay.
like it.
Okay, back to like chem stuff. If I have this reaction, 3H2 gas. 3H2 FN2 turning into 2NH3. Okay? Increasing pressure will shift to the side with less gas molecules to get rid of that pressure. Does that make sense why that would happen? Yes? Travis.
Because when you have increasing pressure, just more stress in a certain area, and you want to relieve.
Not even that question.
99% of the time, yes, but not this 1%. So basically, you're relieving stress. So if you have it's like you take this and like you're pressuring it. If you make a little hole, the water's gonna like escape. Hence, gas molecules are escaping.
That's actually not that bad an analogy. For the most part, yeah, like if let's say I have these two containers, and this one has like a ton of stuff in it, and this one has very little stuff. Which one has more pressure? This one, right? So if I increase the pressure, I want to get rid of that pressure. So I'm going to try to make less molecules. So for this reaction right here, if I increase the pressure, this side only has 2, this side has 4. So an increase in pressure will shift to the right. And I'll make more NH3. If I decrease pressure, I'm going to want to make more molecules. So I'm going to shift to the left. And just a reminder, if you increase volume, you're decreasing pressure. If you decrease volume, you're increasing pressure. Good? And the last one, changing temperature. There's a fancy equation you can use. I have no idea what it's called. But ln K2 over K1 is equal to negative delta H over R times 1 over T2 minus 1 over T1. Easy to memorize, right? Yeah, you don't have to know this until the national exam for Chem Olympiad, but there's a shortcut if you don't want to memorize all that. And that's just treating temperature as a reactant or a product. Right? If I have this reaction, A plus
Exhale.
B turns into C. If it's endothermic, where am I adding heat?
You're in the product.
Am I adding heat or is heat being released?
You're
If it's endothermic,
You're adding heat.
I'm adding heat, right? Which means that I can kind of treat heat like a reactant. And if I add more of this, which way is it going to shift? That way. Okay. So, alright, let's put all this together. This equation. This is like one thing you should learn in Chem Olympiad. Give me this equation because I'm going to use it so freaking often. N2 plus 3H2 turns into 2NH3. And we're told that the delta H, my enthalpy for this, is negative 92.4. So does this mean it's endothermic or exothermic? Exothermic, right? Because it's negative. Does that make sense to everyone?
You're losing heat.
Negative, yeah, you're losing heat. So I'm going to put heat over here. Okay. If I add N2, which way is my reaction going to shift? Right.
Quick side question. If you were to add heat in this case, would it shift to the left?
Yeah. Okay. To people who haven't learned equilibrium yet, so like juniors, minus you, I guess, do you guys get what shifting means? Kind of? Not really? No? Not at all?
Aakash is like 2
Okay, yeah, I guess I should have gone over that more. Okay, let's not think of it in terms of shifting. Let's think of it in terms of what am I going to make more of and what will be used of, right? So when I say a shift to the right, that means that I'm going to make more of that and I'm going to use that up more. Does that make sense? Is that a bit clearer? That if I have, let's say, like, I don't know, 5 of these, 10 of these, and, well, it's going to be a really bad ratio. 15 of these, and 10 of these at equilibrium, and I shift to the right, that means that I'm going to use these up and make more of these. So I might end up with 12, 10, and 4. Does that make sense?
Yeah.
Make sense?
Yeah.
Okay. Okay. So, you know what? Instead of shifting, let's say amount of NH3. What's going to happen to it? If I add N2, it's going to go up or down? Up. If I add NH3, wow, okay, that's stupid.
Can't tell.
Yeah, let's not do that, because then that kind of ruins the recipe. If I add N2, which way is my reaction going to shift?
Right.
To the right. If I add NH3, which way is it going to shift? Okay, what does that mean? If I add NH3, my reaction is going to shift to the left, meaning that I'm going to use that up and make more of these. Right? Does that make sense? Okay. If I increase my pressure,
Right.
why is it going to shift to the right?
You want
less molecules.
You want less gas molecules. I have 2 over here, and I have 4 over here. So if I increase the pressure, I want to get rid of that pressure, and I will shift to the right. If I decrease the pressure, to the left. I want to make more gas molecules, right? I want to increase my pressure. Okay. And if I increase my temperature,
Left.
why is it going to be to the left?
Because the heat is being released, so it's kind of like you're putting things into the product.
Right? We're treating heat like a product. We're going to say, yep, since it's exothermic, since we're releasing heat, we're just going to put heat here in our reaction. And if I increase my temperature, I'm increasing heat, which means it's going to go that way. If I decrease my temperature,
Wait, increase in heat was left, right?
yeah.
It should be to the left for the increased heat.
If I decrease my temperature, I'm taking away a product, right? Which means I'm going to want to make more of it. It'll shift to the right. Yes, you are correct. Does that make sense? If I gave you a problem like this and said, if I add NH3, which way is it going to shift? Do you guys think you could do that? Okay. Great.
He's gonna give us some.
Because I compiled an entire sheet full of problems like that.
Where do you find this time, Aakash?
I don't do my homework.
He doesn't sleep, are you kidding?
That too.
How much do you sleep? No,
He's
serious.
like up at 2 in the morning.
You're kidding me? 11, like senior year, 11 a.m. Once it hits 11 a.m., I'm in bed. Like screw everything. Like, I drop everything and I go
show
to
up to first,
Like,
second,
I only
and
have-
like third hour.
Seventh. I have like 2 gears of sleeping, right? So like I either have sleep for a week, or sleep is for the week.
bed. I've seen that on the
There's no
internet,
in between,
Aakash.
Okay? But it's so true. Like I will either stay up all night doing whatever, or like I'll go home and fall asleep and wake up the next morning and not want to go to school because I'm still sleepy.
I mean, you get your shit done though. I can't.
Okay,
Like,
so
Yeah, right.
yeah, feel free to do this if you want. I'd like it if you do, but if you don't, I'm not gonna beat you or anything. From the one side, I have practice or past AP exam problems, all about equilibrium. And on the other side, there are kind of like
I think I've
questions.
done this before.
So give it a shot. See if you can do it. Some time to it. Mom, do you have to go?
No, probably leave, yeah. You think you can...
Laptop? Yep, we got it. I'm
Okay.
not gonna do anything wrong.
Well, just keep in mind that, like, if someone gets a chemical burn and I'm gone and I left you in here, then I'll get fired.
Oh, we won't fire
And
you.
then,
We'll try not to bring.
I don't worry about you firing me. But anyway, Mrs. Harrison sounds like she's going to be here, so if any emergency comes up.
Okay.
And then don't be long, though.
Yeah.